Welcome to another Blueprint IoT video, and today we will take a look on how to identify the value of resistors. So normally the appearance of resistors is blue or also this yellowish color. But let's go back to the blue one. Beside the base color, there are normally a bunch of rings or colored lines around the resistors. This can look like this, with a bunch of space on the right hand side, or like this, with a bunch of space between the third and the fourth colored ring. This is supposed to help you with the orientation of the resistor, where to start counting and where to stop counting. But what do we count at all, and how to identify the value of the resistor? So let's take a deeper look on the meaning of those colored rings. So the right hand side ring, the last ring in this order, will provide you the tolerance value of this resistor. So the tolerance refers to the manufacturing precision of the resistor, so whether it's supposed to be 100 ohm and now it's 110 ohms or 90 ohms, or is it 101 and 99 ohms, depending on if it's 10 or 1% of tolerance. But we will take a look on this in more detail later. The next ring is the multiplier. So just imagine you have a 10,000 ohm resistor. Of course you cannot write a 1 with 4 zeros in a row on this little resistor, so you use a multiplier, or even think about mega ohm. So you basically have a number, the first two rings as a digit, and then you have a multiplier to increase or decrease the actual value of the resistor. And as already mentioned, the first two rings are the values of the resistor itself. And once more, you identify the direction how to read the resistor by the spaces between the rings. So option 1 is that this space between the tolerance ring and the other rings is bigger than the space between the two first value rings. The other option is to look at the space at the right hand side, which will be bigger between the tolerance ring and the end of the resistor compared to the distance between the first value ring and the beginning of the resistor. But some of you may wonder already how to represent values of 1.27 ohm with only 2 digits. So that's absolutely true, and that's why we have to introduce another ring, a fifth ring. So by introducing this additional ring, we increase the digits we can represent on our resistor, and so for the precision of a value we can represent. Of course, this needs to be represented in the manufacturing tolerance as well. So in case this additional ring is introduced, this ring here in the middle is also a value. So we have the first 3 rings as value digits. The next one is the multiplier, and the last one is the tolerance again. But let's finally figure out which value this resistor represents. So the first ring, the brown ring, is a 1. The second one, the red one, is a 2. And the third one, the purple one, is a 7. So we have 127. The silver multiplier indicates that it's multiplied by 0.01, and the red tolerance ring indicates 2% tolerance. So in total, we have a little math equation. 127 times 0.01 equals 1.27 ohm at a 2% tolerance. So to represent this 1.27 ohm resistor, we need a color code with 3 digits for the value, a tolerance, and of course a multiplier. So a multiplier cannot only increase, it can also decrease the value. In case it would be only a 1.2 ohm resistor, we could skip the purple ring, and 4 rings in total would be enough instead of 5 rings. So the number of the rings depends on the digits you need for the value, and the way the rings are arranged or positioned really depends on the manufacturer. But let's dive into the color code. To identify all those colors, there are normally a bunch of tables available. Those are all representing the same thing, but may be arranged or visualized in a different way. So in case you don't like mine, just Google it and you get a bunch of other options. So each color represents a number, and that's how you can figure out the value. And of course, each number for the multiplier represents a multiplier, and some of the colors also represent a tolerance. So what you probably spot already, that there are some empty fields, and in this case it's because we only need 10 numbers from 0 to 9, and we don't need any more, but we need more multipliers. So the decreasing multiplier colors need no additional number for the values. There are also empty spots for some colors at the tolerance field. That's because not all tolerances are classified, they are just classified into certain ranges. So everything between 0.5 and 1% tolerance would be a 1% tolerance resistor. So that's really just because of the way it's manufactured and the way the manufacturers classify the resistors. So don't wonder why there are some empty fields. But now let's take a look on some of the tricky things with those resistors and why so many people have trouble to identify clearly what value the resistor represents. Let's take a look on the second color, for example. This color is supposed to be gold, while we also have this color, which is supposed to be orange, and this color, which is supposed to be yellow. I already say supposed to be because even from my table it's quite difficult to see the difference. What's super difficult is to spot this difference on a tiny resistor. Remember, those things are normally something like 0.5 millimeters in length, and the diameter is maybe between 1 and 2 or 3 millimeters depending on the performance of the resistor. So to identify these colors is super difficult because it's tiny, because the color difference is not very significant, and also sometimes the printing of those rings on the resistors are not as good as you wanted. But it can get even worse. There's silver for 10% tolerance and also gray for 0.05% of tolerance. And that's a huge difference in tolerance. That's a factor of 20 in between those two tolerance classes, and they look so similar. So it's super difficult to identify this clearly. Also, white could be misunderstood as silver or maybe even gray. So in case you struggle with this table, there are also a bunch of apps for your phone where you can just select the color and it will translate it to the actual value for you. But in case you struggle with identifying the right color, which can be really difficult, even in our example we can see the purple and the red is next to each other and could be misunderstood for one and each other. Also red and brown can often be misunderstood for each other. So what I can really recommend you is to just measure the value of the resistor. To do so, there are some tricks how to do it, and it's not as straightforward as you may think. So make sure to check out our video about how to measure a resistor. And in case you're interested in more content like this and other content around IoT, make sure to be subscribed, like the video, and thanks for watching. See you next time.